Myself, Dr. Susmitha. I am working as Assistant Professor in Chemistry in Institute of Aeronautical Engineering. Today, we are going to discuss about hardness of water, which is a part of water technology. By end of this topic, you will be able to distinguish between hard water and soft water. You will be able to know what is hardness of water, what are the reasons of hardness, and you will be able to understand the units of hardness, expression of hardness of water. Along with this, we will be working some numerical problems on units of hardness and their interconversions. Along with that, we will be working on calculation of temporary, permanent, and total hardness of water. So let's get into the topic. Water is a very important component in life. Water is very much required for the survival of not only human beings, but also for the plants, animals, and all living organisms require water for their survival. That's why water is very much important and very important topic, and you have to know about the water and its chemistry. What are the main sources of water? The main sources of water are the rain, rivers, streams, oceans, wells, glaciers. So many sources of water are there. Among them, rainwater is the purest form of water. Though it contains some dissolved gases like carbon dioxide and oxygen, but rainwater is the purest form of water. Talking about the applications of water, water is used in our day-to-day life, that is in domestic purposes, and in irrigation we use water, and along with that it is also used for the generation of power. So many applications are there. Talking about the industrial applications, it has three main important applications. Water is mainly used for the production of steam. It is used as a supercoolant because it has the capacity to cool the heated substances, and it is also used as a solvent. So the three main applications of water are the production of steam, coolant, and solvent. Talking about the chemistry of water, you can see the molecular formula of water is H2O. H2O. It means one oxygen molecule is present along with two hydrogens, oxygen and two hydrogen atoms. So H2O overall it forms a water molecule. Talking about the hybridization of water, it is sp3 hybridized with a bond angle of 104.5 degrees and an angular structure. If you see here, the oxygen, it is attached to the hydrogen atom with a single bond. The single bond represents the sigma bond. If at all two bonds are present, one will be the sigma bond, then the other will be the pi bond. So the oxygen atom in water molecule, it is attached to two hydrogen atoms with a sigma bond. So overall two sigma bonds are present, and the oxygen atom contains two lone pair of electrons. So in water molecule, two sigma bonds and two lone pair of electrons are present. That's why it got sp3 hybridization with angular structure. Now, there are mainly two types of water. One is a hard water and the other is a soft water. Let us see what is hard water. If the water contains the salts of calcium and magnesium, that is the chlorides, sulfates, nitrates, carbonates and bicarbonates of calcium and magnesium, that water is considered as hard water. Hard water means it will contain these salts. Okay. Now, the soft water means if the water is free from these ions, that water is considered as soft water. Let us see here, I have taken a beaker which contains some salts. Here, the blue colored part, they represent the salts of magnesium, and the red colored ones, these represents the salts of calcium. So, the salts that are responsible for making the water hard are calcium carbonate, that is CaCO3, calcium bicarbonate, CaHCO3 taken twice, calcium chloride, CaCl2, calcium sulfate, CaSO4, magnesium carbonate, that is MgCO3, magnesium bicarbonate, that is MgHCO3 taken twice, magnesium chloride, MgCl2, magnesium sulfate, MgSO4. Apart from this calcium nitrate, magnesium nitrate, or these are also responsible for the hardness of water. As usual, I think you know the salt means salt, it will be a combination of cations and anions. So, if I take up the example of calcium carbonate, calcium is a cation and carbonate, it is a anion. So, the salt, it is formed by the combination of a cation and an anion. So, these salts, all these salts that were represented here, this one and this one, all these salts are responsible for converting soft water into hard water. If these salts are present in water, the water is considered as hard water. It's not necessary that all these salts must be present in water to call it as hard water. Only if one or two or more than two salts are present in water above permissible limit, then that water is considered as hard water. Already I said the soft water means if the water is free from the above said ions, then that water is said to be soft water. So if anyone asks about the definition, how to define the soft water, you can say as if the water is free from the salts of calcium and magnesium, that is the chlorides, sulfates, nitrates, carbonates and bicarbonates of calcium and magnesium, then that water is said to be the soft water if it is free from these specific salts. Now, let us know about the causes of hardness. See, on the surface of the land, that is on the earth, some parts of the land are rich in limestone and dolomite. Limestone and dolomite means those are rich in calcium and magnesium ions. So, when the rain falls, means already I told you the rainwater is the purest form of water. Already I told you rainwater is the purest form of water, though it contains some dissolved gases like carbon dioxide and oxygen. When this rain falls on the surface of the land, which is rich in calcium and magnesium, means it is rich in dolomite and limestone. If the land contains more reserves of dolomite and limestone, we can say that that land contains more amount of calcium and magnesium ions. When the rainwater falls on such kind of land, and when rainwater flows on the surface of those lands, the calcium and magnesium ions will mix along with water. And during the course of time, there will be a series of reactions where the salt formation can take place. Let me take up an example. The rainwater, it contains carbon dioxide. Rainwater, there is possibility that the rainwater may contain carbon dioxide when it falls rain, because the dissolved gases will be, already I told you the rainwater contains carbon dioxide and oxygen. So the carbon dioxide that is present in water can combine with the calcium and result in formation of calcium carbonate. In that way, the salts that are responsible for hardness can be formed. So the main reason of the hard water formation is when rain falls on the surface of the land which is rich in calcium and magnesium ions, there is possibility that these ions can mix with water, and in course of time the salt formations can take place. That is the calcium chloride, magnesium bicarbonate, all these salts formation will take place. And that water, because of these salts formation, that water is called hard water. Now, till now we have learned what is hard water and what is soft water. Now, let us see the proper definition of hardness of water. The hardness of water is the property of water that doesn't give lather with soap. Means the hard water has the property that doesn't give lather with soap. It's called hardness of water. It can be better understood by taking this example. I have taken two conical flasks, one with soft water and the other with hard water. Here I have mixed both the conical flasks with the soap. Means I have mixed the soap in both the conical flasks. So, if you observe soft water carefully, the lather it is formed and the water is almost very clear. This is a lather. But if you observe hard water, here the hard water almost precipitated. Precipitation has formed in the hard water and the lather is almost negligible. Means the hard water will not form lather with soap. So in simple terms, hardness of water is the property of water that doesn't form lather with soap. Now let us see the chemical reactions involved in this. Soap, it is mainly made up of sodium stearate. The soap, it is composed of the stearate ions, that is C17H35COO-. These are called the stearate ions. The soap, it is mainly composed of sodium stearate. When soap comes in contact with hard water means calcium and magnesium ions. The sodium will be replaced by the calcium, resulting in the formation of calcium stearate. This calcium stearate is a precipitate. It will be in the form of a scum. That's why the hard water will not give lather. Instead, it will form precipitate. As you have seen in the previous slide, the hard water solution, it can show it is very unclear and you can see the white colored precipitate formation. That is because of the formation of calcium stearate. If you go through this simple equation, the calcium sulfate, it represents a hardness causing salt. Calcium sulfate is hardness causing salt. When this calcium sulfate reacts with the sodium stearate, what will happen? This sodium is replaced by the calcium. Yes, this sodium, it is replaced by calcium and result what is formed? Sodium sulfate is formed. Sodium sulfate is a byproduct. Okay, because of formation of calcium stearate, the precipitate formation has taken place and that is the reason why lather has not formed. Now, what are the main disadvantages of hard water? We were studying what is hard water, what is hardness of water. First of all, what are the disadvantages that we face because of this hard water? If we see the day-to-day life, we mainly use water for washing utensils, for washing clothes and all. If hard water is used for this washing purpose, the quality of the soap will decrease because the lather will not be formed properly. So the cleaning quality of the efficiency of that soap will be decreased. And if we drink hard water, instead of drinking potable water, if we drink hard water, the digestive tract will be disturbed. Mainly, we will be facing some urinary tract related problems. So we should not drink water that is above the permissible level of hardness. If we see the problems that are faced in the industries, for example, in sugar industries, crystallization, it is a very important step in the processing of sugar. So, if hard water is used in sugar industries, that crystallization step will not take place properly. So, obviously, that will be a loss. The quality of the sugar and the time, money, everything will be in loss. If we use hard water in paper industry, the quality of the paper will not be good. And apart from that, if we use hard water in pharmaceutical industries, the undesirable products formation may take place, because of which the whole manufacturing process will be in vain. So, usage of water, that is the soft water and hard water differentiation and its proper usage must be taken in industries, especially in industries and especially in pharmaceutical industries, because if we use hard water during the manufacturing of the drugs and all, some other byproducts, there is possibility that some other byproducts may be formed. Apart from this, so many disadvantages also are there. These are the main disadvantages. Now let us talk about the classification of hardness of water. Already I told what is hardness of water. Hardness of water is the property of water that doesn't give lather with soap. Why is this hardness caused? Because of the presence of the salts. Now the hardness of water is classified into two types. One is a temporary hardness and the other is the permanent hardness. Okay, the name itself, from the name itself, we can easily grasp. Temporary hardness means it can be removed. It is a temporary thing. Permanent hardness means it is difficult to remove. It is a kind of permanent thing. Some chemical treatments are required to remove that permanent hardness. Now let us see what is this temporary hardness and what salts are responsible for this temporary hardness. The temporary hardness, if the water contains the salts of calcium carbonate, magnesium carbonate, calcium bicarbonate and magnesium bicarbonate, then that water is called the water that contains temporary hardness. So, the carbonates and bicarbonates of calcium and magnesium are responsible for temporary hardness in water. So, this temporary hardness can be easily removed by simple boiling. Carbonates means CO3 minus and bicarbonates means HCO3 minus. So, if we heat, these are the series of reactions that are taking place and carbon dioxide will be escaped in the form of a gas. And these are the reactions that will take place in hard water if they contain the salts that are responsible for causing temporary hardness. So easily temporary hardness can be removed by simple boiling. Now let's talk about permanent hardness. The chlorides, sulfates and nitrates of calcium and magnesium are responsible for permanent hardness. This permanent hardness of water cannot be removed by simple boiling. Specific chemical methods like ion exchange method, so many methods are there. We will be discussing in the upcoming videos. So, some chemical methods must be employed for the removal of the permanent hardness. So, temporary hardness is caused because of the carbonates and bicarbonates of calcium and magnesium. Permanent hardness is caused because of the presence of chlorides, sulfates and nitrates of calcium and magnesium. So overall, total hardness means it is the sum of temporary hardness and permanent hardness. This is total hardness means temporary hardness and permanent hardness. This one you have to keep in mind because we will be working out problems in the further slides where this is used. Total hardness means temporary hardness and permanent hardness. Now, hardness, already I told, so many salts are responsible for causing hardness in water. Among these, calcium carbonate is chosen to express the hardness of water. So many salts are present. You have seen in the previous slide, so many salts are responsible for hardness. Among this, calcium carbonate is chosen to express the hardness of water because of the two properties. One is a molecular weight of calcium carbonate is 100 and it is easy for numerical calculations. Second reason is calcium carbonate is insoluble in water. Because of these two reasons, calcium carbonate is chosen to express the hardness of water. Hardness of water must always be expressed in calcium carbonate equivalence. Now, there is a formula to express the hardness of water in calcium carbonate equivalence. The formula is weight of the hardness causing salt. Hardness causing salt means it can be either magnesium chloride, magnesium carbonate, magnesium bicarbonate, calcium bicarbonate. It can be any salt. Weight of the hardness causing salt that is present in hard water divided by the molecular weight of the hardness causing salt into 100. You can see it here. Hardness causing salt in terms of calcium carbonate equivalence is amount of hardness causing salt, means weight of the hardness causing salt by molecular weight of hardness causing salt into molecular weight of calcium carbonate. Molecular weight of calcium carbonate is 100. So, in simple terms, if you want to remember the formula of expression of hardness in terms of calcium carbonate equivalence, you can simply remember by taking weight of hardness causing salt by molecular weight of hardness causing salt into 100. Next comes the units of hardness. There are several units of hardness. Apart from the hardness is expressed in terms of ppm, milligrams per liter, degree Clark, degree French. Apart from this, EPM is also used to express hardness of water. Mainly these 4 units are used. Now see, the ppm is one of the unit mostly used to express hardness of water. Milligrams per liter is also used. So this ppm it is the number of equivalent parts of calcium carbonate present per million part of water. ppm means parts per million. So the milligrams of calcium carbonate present in million parts of water is termed as ppm. Similarly, milligrams per liter, it is the number of equivalents of calcium carbonate present in 1 liter of water. Milligrams of calcium carbonate in 1 liter of water. ppm is a millionth part of the water. Next, coming to the degree Clark, it is the weight of equivalent part of calcium carbonate present per 70,000 parts of water. Okay, next coming to the degree French, it is the number of equivalents of calcium carbonate present per 10 power 5. Degree French, it is the number of equivalent parts of calcium carbonate present per 105 parts of water. So, these are the units that are used to express hardness of water. The relation between these hardness is very important. That is, 1 ppm is equal to 1 milligram per liter. That is equal to 0.07 degree Clark and 0.1 degree French. There will be problems where we have to interconvert the units of hardness of water. In those problems, this equation will be very useful. That is, 1 ppm is equal to 1 milligram per liter. That is equal to 0.07 degree Clark. That is equal to 0.1 degree French. Now let's jump into the numerical problems. First, we should always express hardness of water in terms of calcium carbonate equivalence. So, in order to express hardness in terms of calcium carbonate equivalent, I have already told the formula: weight of the hardness causing salt by molecular weight of the hardness causing salt into 100. Here is a problem. The water sample contains 60 milligrams of magnesium sulfate. Magnesium sulfate, it is one of the hardness causing salt. That is sulfate of magnesium. 60 milligrams of magnesium sulfate is present in 1 liter. Okay. So, the weight of the hardness causing salt is 60 milligrams in 1 liter. We have to calculate hardness in terms of calcium carbonate equivalence. It is just a simple substitution. You know, molecular weight of magnesium sulfate, it is 120. Next, amount of equivalence in calcium, the hardness in terms of calcium carbonate. Hardness of water in terms of calcium carbonate is here. The hardness causing salt is magnesium sulfate and the weight given is 60 divided by molecular weight of magnesium sulfate, it is 120 into 100. Okay, if you want to know how to calculate molecular weight of magnesium sulfate, magnesium it is 24, sulfur 32 and 4 molecules of oxygen is present. So, 64. It is 10 and 120. Like this, you have to calculate the molecular weight. If you know how to calculate the molecular weight of the salts, you can easily solve these problems by using the simple formula, weight by molecular weight into 100. Now, the second problem is the interconversion of units. You know, the hardness of water, what are the units of hardness? That is milligrams per liter, ppm, degree Clark and degree French. Those are mostly used as units for expressing hardness. So here in this problem, hardness of water sample collected from the tap of a park is 140 ppm. They have told the hardness in terms of ppm. What's the equation? What will be the hardness of water in degree French? You have to recollect the equation, the relation that is in between the milligram, ppm, degree French and degree Clark. Already I told 1 ppm is equal to 1 milligram per liter. This whole equation you have to remember to solve this problem. They have given the ppm and we need to express it in terms of degree French. So you can extract 1 ppm is equal to 0.1 degree French. By using this equation, you can find out, you can express, you can convert the ppms into degree French. 1 ppm is equal to 0.1 degree, then 140 ppm is equal to how much? How many degree French? It is 14 degree French. Simple calculation. The only thing you have to remember is this equation. Now the last problem is a sample of water is found to contain the following dissolved salts in milligrams per liter. What are the salts? Magnesium bicarbonate is present in water, calcium chloride is present, calcium bicarbonate is present, magnesium sulfate and magnesium chloride. All these salts are responsible for hardness of water, and they have given how much amount of these salts are present in 1 liter of water. Okay, so 1 liter of water contains how much amount of magnesium bicarbonate? 73 milligrams of magnesium bicarbonate. They are asking us to calculate the temporary and permanent hardness, and along with the total hardness also they are asking to calculate. The first and foremost thing you have to keep in mind is we should always convert the weights in terms of calcium carbonate equivalents. Then only we can find out how much amount of hardness is temporary, permanent or total, whatever it may be. How much amount of hardness is present, we can calculate. The first thing you have to do is express the hardness in terms of calcium carbonate equivalents. In this particular problem, they have given magnesium bicarbonate, calcium chloride, calcium bicarbonate, magnesium sulfate and magnesium chloride. All these salts are responsible for all these salts are responsible for hardness. Next will be the how much amount. Already in problem they have given. Magnesium bicarbonate, it is 73, 111, all this they have given. Next step is calculation of molecular weights. We have to calculate the molecular weights of all these salts. Next, we have to express in terms of calcium carbonate. We have to express hardness in terms of calcium carbonate equivalence. You know the formula? Weight by gram molecular weight into 100. So, if we take magnesium bicarbonate weight they have given is 73 and gram molecular weight of magnesium bicarbonate is 146 into 100. Okay, that is equal to 50. In this way, you have to calculate for all the salts. Let us take up another one. Calcium chloride. Calcium chloride. Molecular weight of calcium chloride is 111. Calcium it is 40. For calcium it is 40. For chlorine it is 71. 35 point means for chlorine 2 atoms are present. No, that's why we have to write down 75. So if the molecular weight of calcium chloride is 111. In this way, you have to calculate the molecular weight and then start expressing the hardness in terms of calcium carbonate equivalence. Know the formula: weight by gram molecular weight into 100. What is the weight of calcium carbonate? It is 111 by this is the weight of calcium carbonate they have given. What is the molecular weight of calcium carbonate? It is also 111 into 100. That is 100. In this way, we need to calculate for calcium bicarbonate, magnesium sulfate and magnesium chloride. After calculation means after expressing the hardness in terms of calcium carbonate equivalents, we should know which salts are responsible for causing temporary hardness and which salts are responsible for permanent hardness. Temporary hardness means carbonates and bicarbonates. Temporary means carbonates and bicarbonates of calcium and magnesium. Permanent means chlorides, sulfates and nitrates. Okay. So, if we see these salts, this magnesium bicarbonate is responsible for temporary hardness, calcium chloride permanent hardness, calcium bicarbonate temporary hardness, magnesium sulfate permanent hardness and magnesium chloride is also responsible for permanent hardness. So, temporary hardness causing salts are, what are the temporary hardness causing salts? Magnesium bicarbonate and calcium bicarbonate. I have written these two salts. What is their expression in terms of calcium carbonate equivalents? One is 50 and the other value is also 50. So, temporary hardness, the amount of temporary hardness causing salts is 100 milligrams per liter. Permanent hardness causing salts are calcium carbonate 100, magnesium sulfate that is 33.3 and magnesium chloride that is 100. If we add all these three values, we will get 233.3 milligrams per liter. So, permanent hardness causing salts, weight of the permanent hardness causing salt is 233.3 milligrams per liter. In this way, we have found out the temporary hardness and permanent hardness of water. Along with this, they have also asked the total hardness. You know, total hardness is the sum of temporary hardness and permanent hardness. So, total hardness is the sum of temporary hardness and permanent hardness. If we add these two values, you will get the total hardness of water. This is how you need to calculate the temporary hardness and permanent hardness. Let's have a small recap of what all we have learned. So, the difference between the, I think, hard water and soft water. Hard water, if it contains chlorides, sulfates, carbonates, bicarbonates and nitrates of calcium and magnesium, it is called hard water. Soft water means if the water is free from these salts, it is called soft water. Now, the main reason of hardness of water is, already told, that when the rainwater flows on the surface of the land which is rich in calcium and magnesium, those will be carried along with water, and because of a series of reactions, there is a possibility that salts are formed. The classification of hardness is of two types, temporary hardness and permanent hardness, and their units are ppm, milligrams per liter, degree Clark and degree French. Temporary hardness, carbonates and bicarbonates of calcium and magnesium are responsible. Permanent hardness, sulfates, chlorides and nitrates of calcium and magnesium. And we should always express hardness in terms of calcium carbonate equivalents, because calcium carbonate molecular weight is 100, which is easy for calculations, and the other is, it is insoluble in water. So, we have covered the introduction related to water. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.